This video presents our omnidirectional solid-state mmWave radar perception for UAV power line collision avoidance. The proposed system can detect power lines and thin wires from several meters away and avoid collision with them at high speeds. As UAVs become more common and the build-out of electrical power transmission infrastructure continues, the risk of collisions increases with the potential to cause disruptions to power distribution. The proposed system consists of a small quad-rotor UAV platform equipped with 6 mmWave radar devices. The front sensor has longer range but a narrower field of view, while the other 5 sensors all have shorter range but wider fields of view. A Raspberry Pi 4 interfaces with the radars and autopilot and handles onboard computing. This sped-up test shows the radar detections generated in a power line environment, as well as the outputs of the collision avoidance algorithm. When radar detections are made within the large red avoidance sphere around the UAV, the desired input velocity is corrected based on the tangents to the detections in the sphere. The summation of all tangents is displayed as the magenta arrow, and the corrected output velocity is visualized as the yellow arrow. The red arrow indicates the current velocity of the UAV, and the green arrow shows the desired input velocity from the user, which could be either an autonomous system or a manual pilot. The inner red sphere is the safety sphere. Whenever detections are made inside of it, the UAV immediately rejects itself away from that detection. While developing the system, an interesting phenomenon was observed. The radar sensors typically detect the power line at its closest point to the sensor. In this clip, that would correspond to approximately the white horizontal bar. As the UAV yaws around, most detections from its surrounding sensors approximately correspond to the closest point on the power line. This phenomenon can be utilized to simplify the power line avoidance scheme. In laboratory tests, some potential blind spots in the omnidirectional sensing was observed. To evaluate this finding in the real world, the UAV was commanded to fly towards the power lines at an angle corresponding to the position of one such blind spot. As seen in this clip, the blind spots do not negatively affect the system's ability to avoid power lines. At higher speeds, an e-brake horizon, visualized by a gray cone, extends from the UAV in the direction of travel. If a detection is made inside it, the drone immediately reduces its speed. Once below a safe threshold, normal power line avoidance resumes. The maximum length of the e-brake horizon, and therefore also the maximum allowed speed, depends on the direction of travel. Since the front sensor has a longer range, higher speeds are allowed in this direction. The system is able to detect and avoid wires as small as 1.2 millimeters in diameter, making it useful in environments with wires smaller than conventional power lines.